So earlier in the course, a couple of days ago, we covered brute force protection. And so today, in lesson 13, we're going to extend on that, and we're going to cover what's called distributed brute force protection, which is a new enhancement along with credential stuffing that is now part of our advanced AWAF packaged version of ASM. So let's review a little bit about what we talked about a couple of days ago in what we call our source-based brute force attacks. Now, as a reminder, these can come in a couple of different methods. More often than not, an attacker has found a victim's username for some sort of a site, and all they need is their password. And so they're just going to try to flood the logon page with just an unlimited number of passwords until they find the actual correct password, and they are now entered in as Bob, and they have access to all of Bob's information. That is a brute force attack that's targeting a single username. Then we also have what is another form of, let me go back here, I'll just show this one more time. Another form of source-based is where I'm not sure of their username, but I know their first name, I know their last name, and studies have shown that the average user creates a username that is based upon parts of their first name, their last name, their middle name, and who knows. So another form of a brute force attack is where I just flood the login page with different versions of the user's name. In this case, I'm using one of the most commonly used passwords, hello. And sure enough, we get into this user's Amazon page. So this was a review from a couple days ago. We talked about this. This is source-based, meaning all of the attack traffic is coming from a single source. And we saw how easy it is to set this up with ASM to protect against this. But now we have another type of a threat, or we'll call the threat even bigger, a more expanded threat. So as I just said, source-based attacks generate from a single source. And as we saw earlier, we can set up protection by username, targeting a single username, or coming from a single device or a single IP address, and we have different mitigations that we can do. With a distributed brute force attack, now these attacks are coming from a variety of sources. These could be a whole botnet, and they're trying thousands of different usernames. They're coming from thousands of different device IDs and thousands of different IP addresses. Because of that, the protection we just looked at, that's not going to work because that's protecting from a single source. So this is the new vulnerability that this feature is going to address. So to do that, we're going to configure distributed brute force protection. Now we're going to do this in the exact same place that we configured our brute force protection a couple of days ago on our anomaly detection page. We're going to go ahead and create a whole new one. We could have already had one, the one that we created a couple of days ago, but we're going to create a whole new profile here. As we saw a couple of days ago, you always start by defining the logon page. As a reminder, ASM can only provide brute force protection if it knows a successful login versus a failed login. So we always have to start by having that login page created first. So a couple of days ago, we played with all of this stuff here. Now we're going to go down to the bottom of the page, and we're going to play with this stuff here. So the way that our configuration works, so the way that our settings work, is we have a detection period. So ASM, or this protection, is now looking for just failed logins in general. Failed logins from Bob, Fred, Mary, and so forth. And we all now and then forget our password, and we might have, whoops, that's the wrong password. That happens to everybody. So what we're doing, or what ASM's doing, is it's looking for a certain number of those failed logins from anywhere. From anywhere, from anyone, anyhow, anywho. Within a 15-minute period, this is the threshold we're going to look at in just a second. But before I get to that, if ASM identifies that we are under a distributed brute force attack, then it's going to apply a mitigation. The mitigation is going to be applied for this period of time, 60 minutes. So this is the threshold. We can configure this, but we can set it to never if we want to turn the feature off. We can configure it. So now what this says is, if there have been 100 failed log-on attempts within a 15-minute period of time, we're now under a distributed brute force attack. Again, this isn't related to source-based stuff. This is just from anywhere. Any failed logons. So again, as review, with these settings, if there are 100 total failed logons within a 15-minute period, we are now under attack. And time to talk about mitigation. Now you'll notice, unlike what we saw up here, as a reminder up here, we saw things like alarm and CAPTCHA, alarm and block, alarm and drop. You could literally just drop the request. But you'll notice here, we don't see any block options. We can just alarm, which means we get an alert. Or we can submit a CAPTCHA challenge back to the person. Or we can do a client-side integrity, just submit a JavaScript challenge to see if they're using a real web browser. But what you'll notice is there is no option to block. There's no blocking option. Anyone have a guess? Why not? Imagine if we had been found to be in a distributed brute force attack. We hit the threshold within 15 minutes. And now ASM says, we're under attack. I am now going to give this mitigation for 60 minutes. And if this mitigation said alarm and blocking page, that means any person within the next 60 minutes, any person that submits the wrong password
is being blocked.
They're going to get blocked. And they're going to get blocked for 60 minutes because they're going to be looked at as part of the distributed attack. So we don't want that. We want to just give them the opportunity of saying, yeah, that was a mistake. I'm human. So that's why we have those options there. So now let's look at how this works. Now we're being flooded with all of these distributed brute force attacks from all these different sources. And within just a 4-minute period of time, we have already reached the threshold. We've already gotten well over 100 failed logon attempts. So now ASM says, we're under attack. Now it's time to do mitigation.
Mm-hmm.
So now when all these bots are submitting all these brute force attack requests, they're all going to be sent back a CAPTCHA challenge. They can't respond to that. They're probably using a tool of some sort. So they will just continue to try and keep failing. In fact, what's interesting is if you look at the log of the attack tool, you'll see that it's going to get to a certain entry in its list of a username password, and it's just going to keep trying that one. And it's just going to keep trying that one because it's not going to go any farther in the list. It's just going to keep trying and getting a CAPTCHA challenge and timing out and so forth. Now remember, that's going to happen for 60 minutes. All these users are now going to get a CAPTCHA challenge, including valid users. We probably all are getting used to seeing these CAPTCHA challenges now. This is the way that web applications protect themselves. You may have noticed before that you go to web applications that sometimes you get a CAPTCHA challenge and sometimes you don't. At this point, ASM is going to provide a CAPTCHA challenge for all of our users during our prevention period, but this user has no problem submitting the CAPTCHA challenge, and therefore they will have access to the web server because they're not part of the attack. And that can be happening while all this is still taking place and all that distributed traffic. So that's how that works. With ASM, we also provide really, really nice visibility with a new log file. This is something that's new in ASM 13, B13. It's our brute force attack log. And you're going to see all of the distributed brute force attacks that have happened and all the ones that are current or currently happening, which is really nice. We can see when they happened and so forth. You can also see this interesting, this is the kind of a top level look at this particular ASM. Now right now I only have one virtual server with one security policy, but it's possible I could have 10 different virtual servers with 10 different security policies, and if I did, they'd all be listed here. Okay. And for each one of them, I could see during our threshold that we have right now, in the how many passwords we've set as the threshold, 100 bad passwords, bad logon attempts, we can see where each one is at. Now this one here is well over the threshold. The threshold was set at 75. We're way over that. So this logon stress is a quick indicator that that virtual server is under a brute force attack or a distributed brute force attack. So that's what that logon stress is there to identify. If the threshold was 100 and we were currently at 50 failed logons, this logon stress would be around 50%. So it's kind of a top-level view of what's going on. But then, of course, we can select any one of these attacks and we can see a variety of details about this. Lots of data available here. Under the attack summary, you can see some detections. So we have, whenever we have things like attacks like this, we have detection and then mitigation. So the detection includes things like, well, first off, we've got some top-level stuff here. It's a distributed attack. There's the virtual server. There's the security policy. There's the logon page. Then we have the detection. So this is showing how many logon attempts have occurred up to this point in time. And our threshold. Again, we're well over our threshold. And then down below that, you see some mitigation statistics. How many CAPTCHA challenges have been submitted?
Wow.
How many blocking pages were submitted? How many past CAPTCHA challenges, people that have actually submitted CAPTCHA challenges? And how many total effective mitigations? That's just for this one attack. Interesting stuff. We can also look at all the IP addresses that are a part of this attack. This is showing us all the IP addresses involved in this distributed attack. You can look at all the usernames. These are the usernames that have been attempted. And how many failed logons for each one. So there's a lot of data here. A lot of data available to view that we have, which is really nice. So next question that I always like to pose is, in the room, how many of you will admit that you use the same username and password for your online banking, your Amazon, your Netflix, and so yes, all these web applications that you use? We've been told not to. We've been told that you should really customize your username and password. But let's face it, I'm the first to admit, I'm going to forget all of my passwords and my usernames if I do that. So I hate to admit, but I'm one of those people that uses my same username and password across multiple sites. In fact, over half of users out there use the same credentials, username and password, for all of the different, most if not all of the accounts they create. And the average user has 90, nearly 100 different online accounts for online games and banking and finance, this and that and so forth. So the moral of the story here is if a hacker can identify your credentials for one application, well, they then very likely can access all of your web applications. All they need to find out is which applications do you use? Which banking site do you use? Do you use Amazon, so forth. And this is what brings us to credential stuffing. When you think of credential stuffing, just think of taking all these usernames and just stuffing them in to every possible web application out there. Well, how am I going to get these usernames? This is done through leaked, compromised user lists. So you've seen this in the news before. Different companies, somebody gets access to their username and password list. So let's take a look at what this looks like when they get this list of leaked credentials. This is essentially just a data dump. Could be extremely long, this data dump. And all it is all of the usernames and passwords of the users from this compromised site. Now, that's bad because now the malicious user knows all the usernames and passwords for this site, but that's not their motivation right now. What their motivation is, I wonder if any of these usernames and passwords will work on this online banking site or this online banking site. I wonder if any of these usernames and passwords will work on this e-commerce application. I wonder if any of these usernames and passwords will work on this social networking site. And so they'll just run through one of these tools and attempt all of these usernames and passwords. And what they're going to be looking for are all of the different ones that succeed. So now, once they have this list, they know that these users use that one and so forth. What they essentially end up with is this list. For this online banking site, these are all valid users. For this online banking site, these are all valid users, and so on and so forth. That's the idea of credential stuffing. It's taking all this credential information that was leaked and just shoving it in to every possible site out there. Now, of course, he can log in, or she, the malicious user, can log in as any of these users and have full access to that information. Now let's talk about why this is so dangerous. I think this is already clear why this is dangerous, but let's talk about why it's even more so dangerous. So the user's already got, the malicious user already has the leaked credentials. One of those users is a guy named Bob Smith, and Bob has even followed good standards and has a really good password. And Bob has used that same username and password on all of the different applications they use out there. Their social networking, their work, Salesforce and Slack and Twitter and SharePoint and so forth. That's the username and password for all of them. Because, again, over 50% of users do that. So, interestingly, 81% of computer users use the same password across multiple web applications. That's another statistic I found out. 81%. So this compromised company more than likely is going to reach out to all their users. They're going to say, hey, user Bob, your credentials may have been stolen. You should probably change your password immediately. So Bob, being very savvy and safe, is going to go on and he's going to change his password to something even better over here. So now this site is safe from the hacker. Now where's the problem? Where's the vulnerability? This is safe.
Yes, but the other ones aren't.
What about these? That's right. Unless Bob has the foresight to now go to every single one of his other sites to change those passwords, then this guy here can still use that to get onto all of those different sites successfully. So that's really where the danger of credential stuffing comes into play. So to set this up in the BIG-IP and ASM, very simple. We have one checkbox here. Now this is an additional subscription-based service that goes along with advanced WAF. And what happens is we will get, and you as a customer will get, a database of known leaked credentials. And that information is kept updated. So we have this big list of known leaked credentials. So now, with credential stuffing detection, what we're doing, a little bit different from distributed attack detection, is now we're just looking to see if any 100 logon requests were made for any of those users that are in that known leaked credential list. They may have been successful, they may have been unsuccessful, that's irrelevant. If the logon requests were made for any of those users, that will provide a credential stuffing attack, and will have this same mitigation take place. And you'll still see that occur when we have a credential stuffing attack on our brute force. We can actually even see over here all of the known leaked credentials that have been attempted in this particular attack. So that summarizes our new distributed brute force protection and the additional credential stuffing, both which together are really kind of a component of our new advanced WAF. So you get a chance to play with both of these. You're going to start with the protected web application. It'll be protected from single source brute force attacks. But then what you're going to do is you're just going to use a simple I rule. You've done this before. You're going to use an I rule to change the source IP. And so now all the requests from your Windows workstation, they're all going to come from different IP addresses all over the world. And your single source brute force protection will no longer work. So then you're going to configure your distributed brute force protection, and then you'll see that kick in. You'll see your report, and then you'll finish up with the credential stuffing attack and detection. 60 minutes, and we'll see you after the exercise.